Hi, my name is Karyme Arias, and this is my second argumentative examination. So let's start. First of all, we have to start with the moments of inertia, where they are telling us to calculate the moments of inertia of a unit sphere with this equation with respect to three axes that are x, y, and z, when its density is rho equals to 1. So first of all, we have to do our limits because it's a triple integral. So we have to do the limits of x, y, and z. So here we do the limits with the corresponding using this equation, and well, yeah, and these that are telling us about the density. So first we have to integrate ix with this formula. So we do it like that, and well, the result of this one is 8p divided by 15. Then the second step is to do with I of y, and we integrate that equation, and our result is also 8p divided by 15. And at last, we have to do I to z, and we integrate that equation, and our result is the same one as the two others. This is because the moment of inertia is at the axis, and it's the same because it's a sphere. It's the same. If you divide the sphere, it's the same at the left and at the right. So it's the same. If the figure was different and it wasn't equal, the moments of inertia will change. So this thing say that 8p divided by 15 in the three axes, it's right because it's a sphere and it's equal, and its moment of inertia, it will be the same at all the axes, or well, in this case, at the three axes. Well, then we have the center of mass, and here they are giving us a formula. So they are telling us that we have to calculate the mass and the center of the mass of the cylinder bounded in the equation, and they are giving us the equation. If its density function is given by, and they are giving us the function of the density. So first of all, we have to calculate the mass. So at the same as the first exercise, we have to know the limits, and we have to substitute in x, y, and z. So first of all, we integrate with z. We develop this equation. Well, one thing that I didn't mention at the first is that we are using polar coordinates. So here, an example is here that we are using it. We have to substitute the r, and always we have to multiply by the other r. So here we disaggregated. And well, the first one, our result is 7p divided by 6. And this is the mass. So then we have to know the center of mass. And here we have the other equation for its center of mass, but this is a coordinate, so we have to do it with x, with y, and with z. So first of all, we do this equation, substituting the rho. And well, first we do it with x. We also use the polar coordinates. We use it in this example, in this problem too, and we also use it in the problem one, so you can see it here. Well, we use it, and here it's 0. So the first x, we haven't finished. First is 0. Well, but then we have to use this formula, because this is a constant, so this won't change. So here then we use it and we substitute the mass, and here's the result. So here's the result. So x is equal to 0. We do the same with y, and the result of y is the same. It's equal to 0. And at last we do it with z, and here it changes. And our center of mass is 1.6071. So our coordinates will be 0,0,1.6071. And this is right, because the center of mass is where they will be rotating. So if we put a cylinder, that is our figure, at the floor, and we push it, the cylinder will rotate in the larger part. So it will rotate there. So we know that the center of mass is set, because this is giving the rotational, as it can say it. And well, this is the last thing of my explanation.